One of the tricks of being in information technology is you're probably not going to know everything you need to know about the system you're about to build. In my career, I've worked on GPS systems, I've worked in satellites, I've worked on airplanes, I've worked in taxes, I've worked in food, drug, and dairy, I've worked in health insurance. Each of those things have nothing to do with each other, and none of them was something I learned about in school. So we need to have good methods to be able to learn about stuff. We need to be able to be good learners, and information capture is the start of some of those methods as we need to go through and find out about these systems. So to start the analysis process, one of the best places to start is figure out who are the people who care about this system. Because the information capture process needs to know all of the different needs of the users, of the owners, of the impacted systems, of the customers, of whoever's involved, and blend and merge their viewpoints into a system that meets all of their diverse needs. And what we need to capture from this process is both what it's going to do, but also where it lives. What's the environment? Is it working on a mobile phone? Is it working on a server? Is it some desktop application? Is it part of a business process? Is it something that's completely out working on its own, or something that's very self-contained inside of a specific space? And so we have the responsibilities the software is going to do, but we also need to know where is it going to do it. What is the information it's handling? What are the inputs it's going to receive? What are the outputs that it's expected to produce? And then basically who's interacting with the system? Who's going to derive value from the benefits of the behavior, and who's going to be doing the work of it directly? Now, initially, we want to gather information at kind of a high level. We want to be able to let people capture their thoughts and go in, and interviews is a great way to make that happen. We can sit down with the customer, we can sit down with the users, we can sit down with the administrators and ask pointed questions to get the wheels going. Now, we might want to prime ourselves so we understand the system a little bit. Interviews aren't perfect. We can sometimes get caught up in the perspective of one user a little bit too much. We might trust somebody more than the other because of a title or because of some personal bias. But we do want to set up some initial interviews to be able to get questions out there that are hopefully context free. We don't want to basically bias the process by saying, so if you use the .NET framework, then you're going to get this. You don't want to necessarily lead the needs inside of there, particularly when you know a lot about the domain. You think you have the answer in mind. You should basically try and kind of get a feel for, okay, what is it that's your major problems? What's your major, your major heartburn? What's the friction inside of here? Because sometimes the solution that's being asked for is not even the cause of the problem that's being done. It's just either somebody's pet's project or just the perception of what the problem is. And so the first tier is to understand the goal, the benefits that the customer has that's going to come from this system. And then understand what they think the problem is. And then go back and figure out, did you get enough information out of that? So that's the 3-tier system we want to talk about here, because we don't want to just jump into what system do you think we should build? Because that may or may not be the actual need that's going out there. We often as people don't understand what the primary problem we're trying to battle is. We often jump to the fact of, oh, this is what I need, without giving that reflective time to say, well, what is really the best solution here? I could give you examples upon examples from my career. Just recently I had a project where they were convinced they needed to have a debit card functionality built in, and we found ways to be able to solve that problem without having to totally implement a $1 million debit card system. It might be something that's needed someday, but we can try out a solution that we could get done for tens of thousands instead of $1 million that would hopefully put a dent in the problem. We'll see. And you can always come back and do the more expensive system later on, but this was a staged approach because you get past the perceived need and what the actual need out there is, what the actual goals out there are. So the results of those interviews then needs to kind of flow within the whole set of stakeholders. We want to have each participant be comfortable, but at the same time, we might be stretching their comfort zone a little bit. We need to, get to the point of that they might not know stuff too. We need to figure out what, not just what they know, but we have not, and not just what they don't know, but what they don't know to some degree. We really want to see the holes, and that's why we talk to multiple stakeholders, and we've talked to many people who have different perspectives, because sometimes the administrators might say, oh, well, this is your problem, but they might not realize it's not solving the other needs the customers have in a functional standpoint. Or it's kind of a vague example, but anyway, so the approach here is often to basically go off and probe them and get comfortable and establish rapport, so that way later on you can ask difficult questions and not have that be some sort of invasive, oh, you're the consultant who knows it all sort of thing. You want to be able to work between the different participants and show them you're trying to help them understand their system better, and you're trying to help them come up with better solutions inside of there. So with that, the direct interview really only gets us so far. We can only ask questions about what we think is going on, and we can only understand the context of questions as much as we understand the emerging data that's coming out, the system that we're getting at. And so we don't want the interviews to be the only techniques we have to get information. We want to also add in some other formal techniques, and one instance of that, not by no means the only instance, but one instance of that is what's called a JAD session, a Joint Application Development Session. This comes into ideas from the design thinking space, the study and research of how people design things, where often the problem evolves as the solution evolves. So we might say, the problem I have is I get ants in my kitchen. And as I go off and look at it, what we realize is the problem's not just the ants in the kitchen. The problem is we have a trash issue, because when we put the trash in the trash can, it dumps out. Well, why is that? Well, because we have no space for the trash can to go in the kitchen anyplace good, and so we end up having this tiny trash can that overflows regularly. Well, the problem then comes in the kitchen is the wrong space dimensions, and we need a kitchen remodel. So the problem started off being ants. The solution ended up being a remodel of the kitchen. Now, it's an expensive upgrade inside of there, but it's because our problem evolved as we looked for solutions. When we tried to say different trash can size, it was not possible to put a trash can in there because there's no place to put it, for instance. So we're evolving through this working session. That's the idea of what a JAD does. It gets us into beyond the requirements stage to start talking about what are plausible ways to solve the system. Now, we're not coming up with the solution. That's for the design to come later on. But we do want to talk through, like, what are the different ways we could approach this and say, we're not promising anything. We need to consider it. So within that, it means we have to have both technical and professional skills that we need to solve within that. So we need problem solving within technology. We need to understand how computers solve problems. We might need some domain experience. We might need to come up to speed on ants or health insurance or banking or whatever the domain is that's going to come up there. We probably need to model things. We need to draw things up and be able to represent for ourselves and for our customers, how do we go through and represent systems. We need to know what the systems can do, and we need to be able to be creative in how we engineer solutions. But we also need to communicate well. We need to establish rapport with people. We need to understand how to negotiate solutions, because if we get to the point of working with stakeholders, we might need to balance different viewpoints and different needs, which means we have to organize information and people really, really well throughout that whole process. And so modeling is a really key part of requirements at the highest level. We need to either look at functional decomposition to be able to break down what the system does, which is excellent for data-driven systems that works really well when working with older languages, or we need to do object-oriented system, which scales up the complexities better, that deals with more complex data and more interacting data well. And it's much better at looking at the holes in our understanding of the system, because we can see where data doesn't live. We can see where gaps are missing, or hey, this thing is here. What does it do? We can go figure that out, and that leads more directly to object-oriented type languages. So It is an example of structured analysis modeling. What we do is we take big processes and we break them down into steps. It's called decomposition, functional decomposition specifically. So, for instance, if we talk about preparing a meal, well, what do you need to do starting from scratch to prepare a meal? Well, you need to shop for food, you need to cook the food, then you need to eat the food, right? That's the three steps inside of there. Now, the thing about structured analysis, there's different ways you could break this down. You could add in additional steps. You could reconstruct the way the steps are. You can name them differently. But it is breaking down the system into its component parts. And then we can go further. When I go shopping, what do? Is I drive to the store, I put stuff in my cart, I check out. And again, you could break that down a different way, but this is one way of modeling the systems. Now, object orientation is not so much that one path. Object orientation is all these different viewpoints and perspectives. I might be sitting out in the bleachers and get one view of the game, and then I might go up behind the plate and get a different view of the game, and then you get the idea. There's a different ways of capturing that model. So within this approach, we're going to go look at use cases. Use cases describe, and we'll talk about use cases in great detail. They describe what the system does for the user. From a user standpoint, there's a menu of the different types of things I can see. So I can go to the mobile app and add an item, and I go to the website and view an item. I have no idea what it does behind the scenes, but the idea of this, I just know that these are different things I could choose to do. No particular order to them, no particular sequence to them, but this is the different places I can jump around. As opposed to an activity diagram, which starts to tell me flow and intent. The activity diagram is say, okay, I open the app, and then I get authenticated, then I go add a new item, and then it goes to the update. You can see the flow, the sequence of events that's happening inside of here. It's another view of the system. This corresponds pretty directly to the functional decomposition, but within the context of object orientation. And the difference there is the class diagram. The class diagram represents the things in our system. So in the system we were just talking about, we're storing items maybe for sale or for a collection or something like that. So the item is a thing that we store, and the user owns an item, and they get stored in a collection. They get stored in a shopping cart. Different things that show up in the system, and it becomes important because those things are the actors that show up through the work we have going on inside of our system. So that modeling then becomes the foundation for our information gathering. We start off with the need to find out information from people. We go through and we capture that information through interviews and then through working sessions, and there's different things you'll read about for that. And then ideally, we should capture that in some format, and I'm going to propose to you that models is the best way to capture that emerging data, because words are expensive to write down and evolve over time, where models are very generative. They make ideas. It's something we can talk about. And then when we're ready, we go off and write the words. And that's kind of the process I'd like to see you follow in this class and learn about. Though we're not going to necessarily draw all the models, that's how I hope for you to get to the different text requirements that we're going to write. All right, so we'll continue through this, but this is a start. We'll see more as we get into further weeks.